Today we're going to be talking about section 4.1, which is on graphing quadratic functions. Now, what is a quadratic function? Its greatest exponent is 2, so you're going to have an x squared in it. And it's always of this term, right here, x squared plus bx plus c, where a is not 0. Now, your b could be 0, so that x could be gone, or your c could be 0, and that term at the end, the constant term, is gone. However, you always have to have an x squared. That's what makes it a quadratic. Now, when you graph quadratics, they form what's called a parabola. Okay? And a parabola is a math word that essentially means it's equal on one side of your axis of symmetry as it is to the other. Okay? And we can do this a couple different ways. One of the easiest ways to graph a quadratic formula is by making a table of values. Now, I've taught you this before, and you've seen this before, and generally what we do is we pick the same 5 values. We pick -2, -1, 0, 1, and 2. And just like you've seen before, what you can do is actually go to your calculator, and you can go to the y equals button, and you just put in this value right here, 3x squared minus 12x plus 6. And then you hit table, and you'll see all of those values. And when I do that on mine, this is what I get. I get 42, 21, 6, -3, -6, and if I go down here, you'll actually see that it goes back to -3 and it starts repeating itself again. So if you look at your table of values, you'd see that. So what I'm going to do then is I'm just going to graph those values right there. Those are just points. So -242 is like way up here. Okay? Then -121, boom, way up here. Then we get 0, 6. There. We get 1, -3. 2, -6, then we get 3, -3, and then we get, if you look again, you get 4, 6, and so you see this actually starts repeating itself. And so it goes like that. So parabolas look like a U essentially, and you've seen quadratics before. We talked about that in the last chapter. So there are 2 examples that you can try by making a table of values as well. Now, all parabolas have what's called the axis of symmetry. It's the line that actually goes through the vertex. And all points on the left are the same distance from that axis of symmetry as all the points on the right. So you'll see right here in our example, if our vertex is at 3, -3, that means that my axis of symmetry is right here, and it's going to be x equals 3. It's the line x equals 3. It's that red dotted line. And then you'll see that I have a point right here, which is 7, 1. And so 7 is 1, 2, 3, 4 units to the right of my axis of symmetry. So I go 1, 2, 3, 4 units to the left, and that's how I get my point B, which is -1, 1. Okay? The same goes up top. Okay? Up here, I have 1, 7 units to the right, and I have 1, 7 units to the left. And so they're going to parallel each other. And so that's what makes parabolas so unique. Now, we can find out significant information just from our quadratic equation. The first thing we can find is where it crosses the y-axis. It's our constant term. It's c. Okay? It's right here. That is my y-intercept. So essentially, if I put 0 in for x and x squared, what's going to happen is that c that pops out, that's going to be my y-intercept. Just like in the equation of a line, y equals mx plus b, the part that's added out at the end, that's also your y-intercept. Now our axis of symmetry is super easy to find. It's of this form right here, -b over 2a. Okay, so you take -b over 2a. And so then what ends up happening too is, since that's the axis of symmetry, it's also the x-coordinate of our vertex. So you take that value and you put it into your equation and you'll find out what your vertex is. So if you're a person that wants step-by-step process, it goes like this. Okay? Look at your equation, right here, your quadratic equation, and you find out what's your axis of symmetry. Okay? So for this one, -b over 2a. Okay? So our b is 6, so it'll be -6 over 2 times, and then my a is like a little ghosty 1 in there, so that'd be 2 times 1. So -6 divided by 2 is -3. So now we know that our axis of symmetry right here is -3. I take -3, I put it into my quadratic equation, and when I do that, I get -3 squared, which is 9, plus 6 times negative 3, which is negative 18. So 9 plus negative 18 is negative 9, minus 2 is negative 11. So there's my vertex, is at negative 3, negative 11. Next point I find, since my axis of symmetry is not the y-intercept, or excuse me, not the y-axis, I can find out what my y-intercept is, and that's actually going to be negative 2. So I go over and I find 0, negative 2 right there. And you'll see that it's 1, 2, 3 units to the right. So I count 1, 2, 3 units to the left. I find my other point. And since I know that, I can just connect my dots. And there it is. So step 1, find your axis of symmetry and vertex. Step 2, find your y-intercept. And step 3, connect the dots. All right, so let's look at this one right here. It says, consider this quadratic equation. X squared plus 4x minus 3. It says, find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Okay, so the y-intercept of this one is my constant. So if I put 0 in here, 0 in here, I'm left with negative 3. So my y-intercept is going to be the point 0, negative 3. Now I find my axis of symmetry. Okay. Axis of symmetry in our case is going to be x equals what's negative b, so it'd be negative 4 over 2 times 1, which is going to be negative 2. And then that also answers our next point. What's the x-coordinate of the vertex? The x-coordinate of the vertex then is going to be negative 2. Okay, perfect. So we're already on the way to graphing our equation. Now it says make a table of values that includes the vertex. So when you do this, okay, what you can do is make your table. And generally what I like to do then is take that negative 2 and put it right in the middle. So this will be negative 3, this will be negative 4, and this will be negative 1 and 0. And you'll notice that these two are going to mirror these two, right? So if I put negative 2 into that equation, let's go back to what the equation was. X squared plus 4x minus 3. Right? So I put negative 4 in. I can do this two ways. I can either put them in individually, or I can go to my calculator. So what I'll do is I'll go to my calculator. I go to y equals, and I get x squared plus 4x minus 3. Go to my table. Negative 4 is negative 3. Negative 3 is negative 6. Negative 2 is negative 7. And then it mirrors itself, negative 6 and negative 3. And so since it mirrors itself right there with negative 2, negative 7 being in the middle, that actually helps me realize, okay, I did this right. I found the correct axis of symmetry. Okay? So now it says use this information to graph the function. All right? So remember, the important information was the vertex. Okay? We found that to be negative 2, negative 7. Our axis of symmetry was at x equals negative 2, right? Our x-coordinate was negative 2. We also found that our y-intercept was going to be negative 3, right? So 0, negative 3, which is actually in our table as well. Okay, so the first thing I did to graph it, I say, okay, well, my vertex is at negative 2, negative 7. Okay. I also know that my axis of symmetry is this dotted line right through here. Okay, it's going to be the same on the left as it is on the right. And then I have 0, negative 3 right there. I also knew that negative 1 is negative 6. Negative 3 is negative 6. And negative 4 is negative 3. And I just connect my dots. And there's my parabola. So, not too hard to do at this point. Here's a guided practice problem. You have the quadratic equation, negative 5x squared minus 10x plus 6. So what I'd like you to do now is to find the y-intercept, axis of symmetry, and the vertex, then make your table of values, and then finally graph